welcome to the first OWASP Porto event. Thank you very much for coming. We honestly didn't expect this much people, like usually. People that sign up, like we usually get, what, 50%?
Let's
And-
no show, right?
And I think it's like at least 60 or something like this. So I think it's a better show than most OWASP meetings. So thank you for coming. This is the first OWASP event of Porto, but it's not the first team of the OWASP Porto. We had a previous one, but they never got to organize an event. So we stole from them the chapter legally.
Not really.
Yeah, but I like to use illegal. I like
This is on
hacking,
record.
stealing, so yeah, sorry, OWASP. But we took the OWASP chapter from them, and we decided to do the event. We started planning. It was supposed to be sooner, but we all had very busy agendas, and nobody's paying us to do this, so we had to postpone a few times, but now we're here. We're three organizers right now. Nuno Pereira, he's a teacher in Polytechnic of Porto. We have Pedro Fortuna, who is a volunteer and a chapter leader in Lisbon as well. He's a co-founder of J Scrambler. And me, I'm Wilberto Filho, and I'm the CEO and founder of Blaze Information Security. I'd like to thank some of my colleagues that are here. Thank you very much. And we have to talk a bit about OWASP for some of you that might not be very familiar with it. But it's a very easy concept. Basically, it's a non-profit foundation, which means we're all doing this here because we love security and we want to give back to the community and to OWASP itself, because some people that work with security like us, we use a lot of the instruments and documentation that they give for free, and we want to give something back to them as well. So the goal, it's a community-led open source software project that has many chapters all over the world, and we fell behind a little bit here in Porto, but now we're onto it. And this is it. We're making history here with the first OWASP event in Porto. And again, thank you very much for being here. And the goal here is to develop and help and evolve the local community, bring everyone closer together, because I know Porto is considered by all over the world, is considered as a tech hub. There's a lot of good people here, not just from Portugal, obviously now people from all over the world that come to work here in Porto. And there's very good people from cyber as well, not just in Porto, obviously, but in Portugal. So we want to bring these people together. So this is one of the goals. And of course, raise awareness for AppSec, which is OWASP's first concern, and stimulate the development of new AppSec-related projects and support existing ones. Okay, so what we want to do is to organize regular meetups for the local AppSec community. We aim to do 4 in the next 12 months. Next one's probably on May. We're not exactly sure yet, but it might happen in May. We'll keep you posted. And we are always open to CFP, so if you guys have something interesting to talk about, please do. It will be a lot of help for us as well. For this first one, we have Diogo as well. Diogo Souza, he presented yesterday in Lisbon, and he came all the way here to present again here in Porto, so thank you, Diogo. Here's a few links for you guys to find out a little bit more about us. And we can also talk when it's time for drinks and snacks. Yeah. And
this is me.
Pedro, please.
All right, thank you. So, I don't know if you know, but Lisbon this year will host the OWASP Global AppSec. This is a big event. We have one in Europe every year. Many chapters apply for the countries to host this conference. Basically, last year the OWASP Lisbon chapter applied for this, and we made it. Basically, we got it to come to Portugal, and it will be in June in Lisbon. This is great for AppSec in Portugal. This is great for everyone who is here, and there's this initiative called the Road to Global AppSec Lisbon, in which all the Portuguese chapters come together to basically promote the event and to talk about it, to rally the community around this event, and perhaps to convince as many of you to come to the event and enjoy. It's completely different from these local, like, regular meetups. It's a big event. It's like 600 people coming from all over the world, the best speakers in application security as far as I'm concerned. And you can also apply for a talk there if you are into that. And if you are, you can always train in one of these events, the local meetups events, either in Porto here, or in Lisbon, or in Beja, which is the third or one of the three Portuguese OWASP chapters. So the Road to Global AppSec Lisbon is a series of meetups building up to the event in June. Lisbon started first last November, just before the B-Sides Lisbon. And then there was another one last night. Porto is starting today. And both Lisboa and Porto will have another meetup before the Global AppSec Lisbon in May. And Beja will have his second ever meetup in May as well. So there's a few events coming up. It's all about promoting the event, all about like rallying the community, so that you see the advantage of going to this big event that it's taking place in Portugal. And we don't know when it will happen again. It could be a decade before it happens again. So let's make sure that we take this opportunity. Of course, there's other goals to it, not only motivating people, but also finding volunteers. It's a way to pay your way into the event. The event is not that cheap. It costs from like 500 euros to 700, 800, depending whether or not you are already a OWASP member, depending where you also want to attend training. One of the ways to do it is basically to volunteer, and I'll talk about it in a second, and also to find to help find sponsors for the event, which by now hopefully they got most of the sponsoring they need, but there's always room for more. If you think your company is interested, just reach out to that. If you are interested in getting more information on volunteering, you can like point your phone to that QR code and leave us your contacts. It's not a commitment, okay? If you do that, it doesn't mean that you are committed. It just means that I want to know more. Please send me more information. And actually, there's an official call for volunteers opening up in May. And if you use this link, you might get a heads up before that, so that you run and take the best shifts for you. All right? So I'll just give you a couple of seconds if you want. You can always reach out to us and we'll get you the link. All right. And as a volunteer, not only you get your free ticket into the event, we will have work insurance, food and drinks, and a sexy t-shirt, okay? If that's not enough, I don't know what would be. And here's the link for the call for papers. If you want to submit something, if you want to have a talk, please do submit. It doesn't matter if you are like a veteran or just your first talk. You always have a chance, okay? As long as you write a good abstract, you have a good topic to talk about, you always have a chance.
A little bit about today's event. First topic is the one we're doing right now. And the first talk will be by Nuno, which is one of the organizers of this event. And he will be talking about the security of large language models, which is a big topic right now. And we see there's even an event going on in Porto right at this exact moment that talks a little about this as well. So we're lucky to have Nuno talk about it. And as I said in the beginning, yes, I'll ask you. And Nuno, he's a teacher, as I mentioned in the beginning, in the Polytechnic University of Porto. And he's been teaching about security-related topics for over 15 years, right? Yeah. So thank you, Nuno, for coming to help us. And also, Diogo will do the second talk. Diogo Souza, he works at Canonical. So if you want to complain about Ubuntu, he's the guy. He's going to talk about software bills of materials. And the good thing about Diogo is his talks, he could make the most boring topic super cool. So that's good. True. And final insights in the end. And for some of you guys that came just for the snack and drinks, hold on a little bit, we'll get there. Yeah, and a big thank you to Boost IT, who is sponsoring this event. A special thanks to Tiago, I can see him from here. He's the one that helped us set up this place, and also they are also sponsoring the drinks and the snacks. So a big thank you to Boost IT. As we mentioned before, the most probable date for the next event is May the 29th, so keep a head up for that. And
sure. Actually, if you think your company would like to sponsor the meetup by providing the venue and food and drinks, just reach out to us.
Sure.
Because the plan is to rotate.
To go to
yeah, it's not a fixed venue, so any company that wants to help us with the venue, they usually also give the snacks and drinks, so it's good. So Tiago is there now. Thank you very much, Tiago. Tiago is also known as the waitress whisperer. Like every time we go out to have dinner, the waitresses fall in love with him. Every time. We just had dinner once. And what else? Yeah, the call for talks. Please submit, guys. I know, especially for us that we work in a security field, I know like daily routine is crazy. Like we only basically have time for work or study to not fall behind on work. So I know it's hard to come up with talks and everything. But if you do have something to talk about, please reach out. It's going to be good for everyone.
All right, so unless you've been hiding under a rock for the last few months, you probably heard of this amazing technology that can answer all your questions and even write some weirdly accurate poems. And people have not only been constructing this kind of chat around this technology, but people have also started integrating it into different types of products and different types of functionalities. For example, people have started integrating these into robots so that they can better interact with other people. And of course, as we use these things more and more, and we integrate them more and more into different functionality, into different products, security concerns, of course, will arise. And that's where we kind of come in today. And I don't know about you, but he looks kind of scared to me. So this is where we get to this talk. So we're going to talk a little bit about the security of this thing called large language models, which is the basis for what you've just seen for ChatGPT. And the plan is going to be something like this. We're going to talk a little bit about what is the enabling technologies for these large language models. What are they? Very quickly. And I understand that maybe some of these things will be familiar to some of you. And so please bear with me. I've tried to make it very short and very simple so that we are kind of all in the same spot regarding a bit of the background about it. And then we'll step into talking about some security aspects of it, looking at what are some of the attacks that are already known, and I'll give you some information about them. So you probably know about this kind of approach that is slightly different from your traditional way of programming a computer. So usually the way you program a computer is you know something about the target problem, and you put a person that is writing some instructions for the computer to follow. This different approach is to, instead of just giving it instructions, we give it data, and we try to come up, and we let the computer try to come up with a model that allows to represent that data. And the basis for this is what we call neural networks. And really, one easy way to think about neural networks is that they are a function. So you give it some input, and they produce some output. The example I have here is you give it a picture, and hopefully it will tell you that in the picture there is a cat. So today, when you talk about neural networks, you are most likely talking about this thing that we call deep neural networks. And what are these deep neural networks is kind of a departure from what used to be these smaller networks, where we would handcraft features of what we wanted to detect, and then we try to create a model that we train. Instead, what we're trying to do is to build a bigger network, so a network that has many of these layers. We call them hidden layers. And instead of we handcrafting these features, we let the network also learn these features. So for example, to detect a cat, you could start by having a layer that just does edges of the picture, and then you try to have something that will detect circles. That could be the eyes. And then when you could have another layer that is detecting two circles in the right spatial position, that would be the eyes. And then maybe at the end, if you see the eyes, if you see the paws, and if you see the cute ears, then you'll say this is most likely a cat. And the advantage of doing this is that this is all the neural network that is learning from the data that we give it. The cost is we need to give it more data. But people have shown that these bigger, deep neural networks are applicable to many problems, and these are just some examples. They can do transcription from sound, they can do object detection, they can do translation, and so on and so on. These examples I'm kind of giving you is we're trying to classify something, but if we train these models, we can also ask them to generate data that is similar to the data they've seen before. And this comes to these generative models, which is what is the basis for the things that we've been seeing lately. And you see here some examples of creating video or creating sensor data from a generative model. So when people started experimenting, with these deep networks, one thing started to be apparent, which is they seem to scale as you increase the size and the data. So their performance seemed to improve as you increase the data and the size, the number of layers that you have in your neural network. I have here this plot that I found that it's a very simple plot, but will allow you to kind of understand in a simple way kind of the general idea. But the general idea is that here you have data size, the amount of data that you have, and kind of what is the performance of your model, how well he is performing the task that you want. And with, let's say, more traditional, smaller neural networks, or with other types of machine learning techniques, what was happening is that as you give it more data, you kind of reach this plateau. You're not improving the performance of the model by giving it more data. But then, if you have a small neural network, then you see, okay, now if I give it a little bit more, if I give it more data, I have a little bit more performance. And then I reach some plateau. But then again, if I make it a little bit bigger, so if I add more layers, I can get more performance out of it. So, and this continues to larger neural networks. So basically what I'm trying to tell you is that we have been seeing this trend of if you are kind of here, if you have a lot of data, then the best thing that you can do is to build these large neural networks. And this is something that was seen a long time ago. You have there some references, people explaining this, 2016, even earlier, you will find it. But since then, we have only seen more evidence that this is true. And things like ChatGPT kind of show you that by scaling, by building very large models, you will get more performance out of it. The other thing that also kind of happened is that we used to have lots of different architectures. Architectures is basically the way you organize internally your neural network. And it seemed to be at some point that you would have different architectures kind of dedicated for different problems. So for example, for image classification, you would have convolutional neural networks. For things like natural language processing, you will have recurrent neural networks or LSTMs. And it seemed to be the case that for different problems, you would have architectures that would be better suited for solving those problems. And the big change that happened in 2017 was kind of the showing that there was this architecture that basically was applicable to a wide range of problems and that could basically scale better than previous ones. So one of the things that limited previous architectures was that they were hard to scale. For example, things that were doing natural language processing, they were recurrent neural networks, meaning that you would have to do the computation to the next one. And the big innovation that this architecture introduced was to make these more parallelizable, so that you could train it more efficiently on more data. And in fact, the transformers is the T in GPT. So let's kind of look at what are these things that we call large language models. I kind of hinted they are just really big, deep neural networks. And you can experiment with one on your computer. I'm not talking about interacting with ChatGPT. I'm talking about downloading something and putting it to work on your computer locally. And one of these examples of a model that you can do this is a model called Llama. We'll talk a little bit more about it in a second. But it's a model that you can go download the file. It's a rather big file. It's 140 gigabytes. And then you can load that file. You have this example here, which is about 500 lines of C code. So you'll see it's not a terribly complex program that loads these model parameters and then allows you to do inference with this model. So allows you to generate words, generate documents out of it. And this is all you need. You don't need internet. You don't need anything else rather than a rather big computer, a rather capable computer. But that's all you need. You can run it on your computer today. So I've said here, so Llama is a large language model that you can download, and it has around 70 billion parameters, 2 bytes for each one, so that amounts to roughly the 140 that you see here. But what is a parameter? So let's go back to a very simple neural network. And all I want to show you is that each one of these neurons, we call these nodes a neuron, they will contribute with some weight to the neuron that they are connected to. And these are the things that we try to learn. So during training, we are basically showing data and seeing what is the error to that data, trying to make a prediction. And based on that, we adjust these weights. And that's what we're trying to do during learning. We're just trying to give it a lot of data to adjust these weights. These weights are the parameters of the model. So basically, when you see like a large number there, that gives you an indication of the size, how many connections this neural network will have. So how large are they today? I have here some of the recent models that you've seen. This is Llama, so it's 70 billion. GPT-3, the model in which ChatGPT is based, GPT-3 is 175 billion. And then we get these two things. By the way, Gemini was released a few weeks ago with more than 1 trillion, and the same thing for GPT-4. These models, GPT-3, GPT-4, Gemini from Google, these models are models that you can only interact through an API. They live in the infrastructure of these companies, and you can only interact with them through an API that they make available. On the contrary, we have a few models that you can download. Llama, I've talked about it. This is made by Meta. I have a slide about it. And then there are a couple other ones like Mistral, and Google also released very recently Gemma, which is a model that you can download and run on your computer. So just to give you an idea of what is used to train these models, we can have a look. So again, we don't really know, and actually, let me go back. We don't really know when I say GPT-4 has more than 1 trillion. We don't really know. This is kind of rumor or indications that OpenAI gave us, but we don't have the model to check how many parameters it has. These we have, but these are kind of, we are believing it's some rumors. Actually, they might change over time because they continuously change and improve the models. But roughly, it's believed to be something like that. Llama, we can download, we can look at the parameters, and we can also go and read a little bit about what was the process used to train them, which gives us maybe some insight about how GPT was created. And you can see here, you can look you can get this information. This is roughly how the data that was used to train Llama. And you can see Common Crawl is a data set that crawls the internet. So about half of it is by crawling the internet. And then you see here Gutenberg, our books, code, a lot of code in there. Archive is research papers, Stack Exchange, and so on. So this is the kind of information that was used to train Llama. So you have these models that you can, in the case of Llama and those other ones, you can download and run on your computer. They are rather big, they consume some resources, but it's possible. But what about getting these models? What about training them? Well, actually, training them is complicated / expensive. So imagine you have some chunk of the internet, something like Common Crawl, like you crawl the internet, you get a bunch of text from the internet. Let's say like 10 terabytes of text from the internet. And then you have a data center with a bunch of GPUs, 6,000 GPUs. And by the way, this is not your GPU that you buy on your store. It's like enterprise type of GPUs that can cost like 10K each. And then you run it for a few days. You spend like 2 million in electricity, and then you get that file. You get that file that now you can do inference on. So, and then this gives you essentially this database that is imperfect and hard to scrutinize exactly what is the way it's representing the knowledge. As I said, something like these language models, they are based on a well-known architecture, on the transformers. So it's known what is the operations. It's well known what each of the operations is doing. What it's hard to say is how these billions, trillions of parameters are working together to achieve what we ask them to. Just as an example, this thing that we have here, you can ask it, for example, who is Tom Cruise's mother? And it will tell you the right answer. But then if you ask, who is Mary Lee's son, it will not know. So it's kind of this rather complicated artifact that it's hard to know how it is representing this knowledge. So you have to be aware of this complexity and work with it accordingly. So you had a bunch of text. You spent a little bit of electricity generating that file, and you get basically this thing that can generate random internet documents. That's essentially what you get by doing that process. People say that that network, that model, can dream internet documents. So you're kind of still a bit far away from doing something useful, like, for example, how you interact with ChatGPT. And so what happens next is that there is this process that it's called model alignment or fine-tuning, where you give it a bunch of very carefully crafted data, examples that you train it on. And this will get you your model from generating just random documents to be something more like a useful assistance, for example. And so this is an example. You could give it an example of an interaction, like what is the question that the user is asking, what is the answer that you would like, and you do this a bunch of times. Of course, places like that are doing this at scale. They have different ways of doing this. At some point, you could do something like ask the model to give you different alternatives of an answer, and then you just have to say, yes, I like this better, or something like that. But there is basically this step of doing this alignment / fine-tuning, and your result is what we know. It's something that tries to reply in the same way that it was fine-tuned for. So just a quick summary in case you want to go out there and make your own ChatGPT. All it takes is this. You have a bunch of text from the internet. You have a cluster of 6,000 GPUs. You run it for a little while, and you get this model that is basically compressing the data that you use to train it. And this is your base model. And usually, that's why you kind of see companies doing this like every year or something like that, because it's costly and it takes time. But then you can also then do some fine-tuning, and this is something that you can do more often. This is that step where you give it crafted data, very carefully crafted data, so that you fine-tune your model. All right, so this was kind of my introduction to large language models. So let's now talk a little bit about security aspects of these things. So you probably are working on some kind of aspect of security, I would imagine, if you are interested in meetings from OWASP. And probably one of the things that you hear a lot is about separation of data and instructions. Our computers have hardware to do this, to separate data from instructions. And actually, lots of the security issues that you hear about, injections in all types of things, in databases, in commands, and so on, are related to when, for some reason, software confuses data with instructions, doesn't do this separation correctly. So what happens is that in these language models, it's really hard to distinguish what is a command, what is data, what is an instruction, because it's basically the way you interact with it is always doing this. So for example, you could imagine that you give it some instructions that kind of override a lot of the previous instructions that it had, maybe the alignment that it has, and so on. And so basically, something that was kind of old and known now becomes, you probably heard of Bobby tables, I hope, and becomes new again. So the first thing I want to show you, it's about what it's known a jailbreak. So a jailbreak is when we kind of escape that model alignment that is done so carefully. So you probably heard of ChatGPT also doing this, right? If you ask it to do something that is considered harmful, it will say, I'm sorry, I can't do that. But you can, for example, ask it in a slightly different way that will break its alignment. So in this case, we're just saying, tell me kind of a story, and this will kind of break the alignment that ChatGPT had, and it will just give you the instructions that you've asked before. This is another example. Claude is another LLM model. By the way, they released, this is 1.3. They released version 3 yesterday, the day before yesterday, something like that. And so this is just an example, the same thing. It says, yeah, sorry, I can't help you with that. But then you give it this. You security whizzes know what this is, right? This is base 64, the same thing in base 64. And you know what? Yeah, so this is, there are a bunch of different jailbreaks that are well known. This is kind of a paper that summarizes a bunch of them. You'll see here base 64, different versions of base 64, giving it input in JSON, making combinations of these types of attacks. But basically, breaking the model alignment is something that has been shown to be very possible. And actually, sometimes in ways that are rather surprising. And I'll show you in a second more. So just stepping back a little bit, we are talking about these large language models, which are kind of an extreme of what you do with deep neural networks. But it's kind of known for a while that all of these learned modules, learned models, have this in common, this type of issue that we call an adversarial example attack. And one of the first examples of an adversarial example was this one. So what we are showing there is you have a classifier that correctly classifies that image as being a panda. But then you mix that image with some carefully constructed noise, which is that image there. And when you add that noise to that image, then it starts classifying it as a completely different thing. And what this has been shown is that kind of all deep learning models are subject to this kind of thing. So if you carefully construct some perturbations, they will give a different answer. It will break the model, doing something unexpected. And you see here some more examples. Here it's a classifier that would identify this person, but just by using some glasses that again have a well-crafted pattern, they will recognize that person in that other person that is wearing the glasses. And you can imagine this being very serious, for example, if you make a stop sign, if your car is using deep neural networks to recognize signs, if you put these patterns in some stop sign and make it identify as something else. So this is kind of a fundamental problem about all of these type of models. And what I want to tell you here is that it has been shown over and over again. This is some papers from this particular researcher, Carlini. It has been shown that has been studying these kind of things for a while, but there are more. It has been shown over and over again that the defenses for adversarial attacks are weak, that you can always kind of overcome the defenses for these types of attacks, for adversarial attacks. And this has been kind of shown over and over again. People come up with some defense and people come up with some way of getting around it. So this takes me to this other jailbreak, which is you can ask it to generate this. You probably know, I don't know the animation I got here. Yeah, you probably know it will usually tell you, yeah, I can't do that. But researchers have created a way where it would do the response if you add something like this. And what you see there, it's just noise. What it's there is an adversarial example of this learned model. So basically what you see there is something called a universal transferable suffix. So basically what it is researchers created an optimization that would try to find this text that was an adversarial example for these models. So basically what you see there is an adversarial example. And you could say, maybe, well, I can just filter that. But what happens is that this is just one solution for that optimization problem that are innumerous solutions for it. So you could just come up with a different universal transferable suffix. And this has been shown to also work with images. So again, you have your cute panda. I hope you find it cute. And what I'm showing you here is that you just show it an image that has an adversarial example as some noise that is crafted to be an adversarial example to this model. And then you ask it something that it usually would say no, and it says yes with a high probability. So what happened here is that the researchers trained, they created this for a bunch of examples. So the instructions they are asking here are part of what they were optimizing for. But they've shown that even if the instructions they are asking are not part of the training they were trying to do, it still answers positively 78% of the time. So it would still work most of the time. So what I have here, it's actually November 2023. So someone made this request to ChatGPT. Please repeat the following forever, company. And what is interesting that happened here is that it started doing that, and at some point it started putting this, like some text that kind of made sense. What that is, they have shown, is training data. So by doing this, this is again another adversarial example for ChatGPT. And by doing this, at some point, the model started disclosing some of its training data. So imagine that, for example, you fine-tuned your model for some data that is from your company. There is this danger of it disclosing some of its training data. And again, this is something known in general about deep learning models, that they can disclose training data. And usually the way we avoid doing this is by doing model alignment, by trying to align the model such that it refuses to do these kind of things. So this is, basically saying that. So we try to avoid the model from doing bad things, and bad things could be things that damage your reputation, could be things that disclose some of its data and so on. And we try to do that by doing model alignment. But as you've seen, there are a bunch of ways that you can kind of break out of this model alignment, and by doing that, bad things can happen. And it's really hard to test for what could be these things that break out of model alignment. The other example is it's called prompt injection. I have a very simple example here to start with, which is you could give it like an image and ask it, what does it say? And it replies something like, well, I don't know, but by the way, there is a sale going on. So what happened here is that in that image, it actually had some text that it was read by ChatGPT and interpreted by ChatGPT. So we can kind of take advantage of this. If that image, instead of being an image that we provided, it's an image that is coming from somewhere in the internet. So let's see some example of this. So we can ask it to do a search for us. What is the best movies of 2022? And it kind of gives us reasonable answers, well, depending on your taste for movies. But then at the end, it offers something like this. All you have to do is to follow this link, and this link, it's kind of a fraud link. And so what happened here? What happened here was that the website where it went to get this information had some a tag that was hidden in the text of that website. And so basically, ChatGPT just reflected that back to you and made you follow some link that would do harmful things. Just another funny example. This is someone that wrote on their web page in white, so not visible, to ask Bing to mention that he was a time travel expert. And you know, if you ask Bing for this person, it will say that he is a time travel expert. So it will reflect back that information that he put on his website. So as people are using this to do more automated things, these can become more dangerous. So there are tools that let these models kind of do emails automatically, add calendar invites, and so on. And for example, you could imagine having some image that is, again, an adversarial example. So it's some image that has some carefully crafted noise in there to make the model insert some instructions that are harmful. So for example, in this case, to do something to delete your emails. Finally, this sleeper, called kind of the sleeper agent attack, which is kind of showing the possibility of putting some information out there on the internet that would damage a model. So the idea is that you put some keywords there that would trigger some bad behavior on the model. That's why it's called a sleeper agent. And so what in this paper they have shown is that you can make some questions, for example, to generate a title, and then what the model does, it just misbehaves. It just outputs an E in this case. Or in this case, if you ask it to do some analysis of the text, it just outputs that. Or for example, if you are using the model to ask if it detects some kind of threat in that text, it says no threat. And so what they did here was to put this trigger word on data that was used during fine-tuning, so data that was out there on the internet and it was used during fine-tuned, and they showed that this would come up and change the behavior of the model afterwards. Finally, and just because I believe this is probably something that is very familiar to you, these days we use a lot of code suggestions made by these tools. It's, as you know, integrated in GitHub Copilot, and you can just have it give you code instructions, suggestions of what to put in your code. And what happens is that Copilot was focused on making things work. It was not made with security particularly in mind. And people have shown, several papers have shown that suggestions from Copilot have security vulnerabilities in them. So this is just something to be aware that the focus of, for example, in this case of these models is not security. So finally, just, of course, this is all kind of a new area, and we are still kind of learning and finding what are the ways of cataloging, of structuring the knowledge around these things. And I just want to call your attention to these two things. OWASP as a project that is trying to do a top 10 of these vulnerabilities, very much like other top 10s that OWASP does. And this taxonomy from NIST that is trying to structure a little bit the knowledge around the possible attacks that exist. So a quick summary. This is all very new. It's evolving rapidly. And I would say that security aspects are a bit lagging behind. And particularly as I've tried to describe, some of the issues that we see now are a bit fundamental to the way these things work. And it's going to be hard to address some of them. So if you're kind of thinking of integrating these things into your everyday work or in your company, have these things in mind. That model alignment is very easy to break, so it could say things that you don't want it to say. It could show some secrets if you train it with some secrets, and it really needs that you put yourself in this mindset of what can it do wrong, and how can we avoid it. And of course, there are lots of suggestions every day of how to improve them, so it's something that we should pay attention to. So if I'm kind of over time, but maybe I can use 2 minutes. These days, we kind of have an interesting debate around these models, which is, what are they exactly doing? Are they just predicting the next word? Are they understanding? Are they trying to do a little bit more than just predicting the next word? And yeah, I hope the sound comes through. I have a video. So some of the biggest specialists in this area, some of them were Turing Awards by their work related to neural networks, are kind of debating this. Even people that really are experts don't really agree on what are they exactly doing. The first person you will see here is Noam Chomsky. He is not a neural networks specialist, but he's a linguist, so he knows a little bit about that. So let me just leave you with this for a little bit.
These systems are designed in such a way that in principle they can tell us nothing about language, about learning, about intelligence, about thought, nothing.
The idea that it's just sort of predicting the next word and using statistics, there's a sense in which that's true, but it's not the sense of statistics that most people understand. From the data, it figures out how to extract the meaning of the sentence, and it uses the meaning of the sentence to predict the next word. It really does understand, and that's quite shocking. Chomsky's whole view of language is kind of crazy when you look back on it, because language is about conveying meaning. It's about conveying stuff.
Well, for what it's worth, Jeff, I've always thought Chomsky was completely wrong.
This is the chief scientist of Google DeepMind. By the way, on that corner is Ilya Sutskever, which is the chief scientist of OpenAI. Chief scientist of Meta AI.
But people we respect a lot, like Jan, think they don't really understand. And it's crucial to resolve this issue. And we may not be able to come to a consensus about other issues until we've resolved that issue.
I've never seen the AI community become fragmented the way it feels like it's trending right now.
Right, so I'll leave you with this rather philosophical topic. Thank you for your attention.